video, I will work out two examples to demonstrate when we use z-values and when we use t-values to compute a confidence interval for the mean. Let's begin with the following question. It says, a biologist desires to estimate the average lifespan of urban raccoons in Southern California. She collects a sample of 40 local raccoons and determines that the mean lifespan to be 3.5 years. The population standard deviation is 0.89 years. Compute the confidence interval for the mean with a 99% confidence level. Round final answers to 2 decimal places. So the sample mean, x bar, is 3.5 years. The sample size, 40. The population standard deviation that's going to be represented by the Greek letter sigma, 0.89. Our confidence level is 99%. Since we're given sigma, that informs us that we need to use z-values to compute the confidence interval. So we can turn to table F to locate the z-value. At the very top of table F, we look for 99% and we bypass all the t-values to go to the very bottom of the table to determine the z-value to be 2.58. So that's how we determine the z-value. Our next step is we calculate the confidence interval, which estimates the population mean, using this formula with the z-values. So I will go ahead and use my calculator to type in the value. Let me just enlarge the calculator a bit. So we have 3.5 minus 2.58 times 0.89 divided by the square root of 40. Our left endpoint is 3. Remember, we're rounding to the second decimal place. Since this is 6, add 1 to 3, drop everything else, 3.14. And then we repeat the calculation. What I typically do is I just come up, I highlight the equation, I press enter, and then instead of having to retype everything, I just replace the minus with the plus. And so the right endpoint is 3.86, and that's going to round to 3.86. So the range of values is from 3.14 to 3.86 years. We have another question that will demonstrate when we have a t-value. So once again, it's a similar question. It says a marketer wishes to estimate the average age of people who will purchase a new brand of clothing attire. She samples 9 people and determines that the mean age is 22 with a sample standard deviation of 1.05. Compute the confidence interval for the mean with 90% confidence level. Round the final answers to 2 decimal places. So the sample mean, x bar, is 22. The sample size, 9. Now, in this problem, we're given the sample standard deviation, not the population standard deviation. That's S, is 1.05. So this informs us that we will have to find a t-value. Degrees of freedom is n minus 1, so 9 minus 1 is 8. We can then look up the t-value in table F We locate the confidence level. It's 90%. We go down to 8. That's our degrees of freedom. 1.860 is the t-value. Now the formula we use is slightly modified because we're using t-values. So it's x bar minus t times s over radical n. And so we insert all of our information into the formula. X bar is 22 minus t, the t-value, 1.860 times sample standard deviation, 1.05 divided by radical 9, and then we calculate. So let's go ahead and type in our information. We have 22 minus 1.860 times 1.05 divided by the square root of 9. That's going to give us 21.35. And then I like to just, instead of retyping everything, I like to edit the first equation, change the minus to a plus to get 22.65. And there it is, folks. I'm hoping this helps clarify the difference between the t and the z values when computing confidence intervals. Thanks for watching the video.